Hello everyone. In this video we are going to learn class 10 mathematics chapter 6, and the name of the chapter is triangle. We are going to learn about the similar figure here. Similar figure means a photograph of yours and you. If you keep one photograph nearby you, your own photograph, you take one single photograph, maybe like full size photograph, okay, and you keep nearby you. That photograph and you will not be of the same height, but you are similar to one another. Like that, here also you can see two triangles. One triangle is ABC, another triangle is PQR. Both the triangles are not of the same size. One triangle is smaller, one triangle is bigger, but they are similar to one another. How they are similar? There are certain conditions under which we can say the two triangles are similar. Simply we cannot say all the figure that is small and bigger, all the triangle that is smaller and bigger are all similar to one another. No, not like that. There are some conditions under which we can say the two triangles are similar. Here I have drawn the two triangles and they are similar to one another. Why they are similar? I'll tell you about it. Before I tell you the conditions under which the two triangles are similar, let me tell you about their size, the angles here. As you can see, one triangle is larger, one triangle is smaller, but you'll find it has three angles. In the triangle ABC, you can see there are three angles. Let me show you how the angles, what are the measures of the angle. Here this angle B, let me measure it, okay. See, if you look at this, it is 50 degree. 0, 10, 20, 30, 40, 50. So this angle is 50 degree. Angle B is 50 degree. Like that angle C. Angle C, if I do the measurement, I have to do the measurement from the left 0, left 0, 0, 10, 20, 30, 40, 50, 60, 70. So it is here 70 degree. So this angle B is 50, angle C is 70. Like that angle A is 60 degree. Okay, you can check it out. I can show you here it is 60 degree. Yeah, as you can see here, 0, 10, 20, 30, 40, 50, 60. See, this is 60 degree. I think it's visible to you. Though the triangle is smaller, it has an angle 50 degrees, 70 degree and 60 degree. The same way, here the triangle is bigger in size, but there also you will find the angles are same. Here is 50, here also it is 50. Check it out. See, start counting from 0. 0, 10, 20, 30, 40, 50. Say 50 here. Likewise, this side also it is same as like this. 70, here also is 70. Like that, 60, here also it is 60. So that means what do we find here? Though the triangle is bigger, but the angles are of the same measure. So you may be thinking here the triangle is bigger, so the angle will be bigger. No, not so. 50 degree, here also 50, 70, 70, 60, 60. So when the two figures, one smaller and one bigger, have the same size of the angle, same size of the angle, 50, 50, 70, 70, 60, 60, like that, could be any other angle. I just gave you an example of 50, 70 and 60. Could be any other angle, but angle A equal to P, angle B equal to Q, angle C equal to R. If three angles are equal, then we can say the two triangles are similar. One we find here, all the three angles are equal, that is angle A equal to angle P, another is angle B equal to angle Q, another is angle C equal to angle C is equal to angle R. We find three angles are equal. So if like this three angles are equal, then we can say the two triangles are similar, and these three angles are corresponding angle. Why it is called corresponding angle? Let me tell you. First, before that, let me tell you about the sides. Now, sides. As you can see here, the side AB is 2 centimeter. Here the side PQ is 6 centimeter. AB you can see 2 centimeter, PQ is 6 centimeter. That two are the first two sides. So let us divide that. Say AB by PQ. AB by PQ. What is the value of AB? 2 centimeter. What is the value of PQ? It is 6 centimeter. And if you cancel this two number, how much it comes? 1 by 3. Same way, the another side will take BC and QR. So BC divided by QR. equals to, the value of BC is 5 centimeter and QR is 15 centimeter. Centimeter cancel, 5 1 3. That means there we get 1 by 3. Likewise, if I divide the another side, AC by PR, AC is 4 and PR is 12. AC by PR, the value of AC is 4 centimeter and PR is, you can see there, 12 centimeter. 4 1 3, that means 1 by 3. Now in all the three cases, you find when you divide all the three sides of the triangle, you find the answer to be same, that is 1 by 3, 1 by 3, 1 by 3. That is called proportion. That is called proportion. That means the ratio of all the sides are equal. Therefore you can say AB by PQ equal to BC by QR equal to AC by PR. These are called proportional sides. Sides are proportion, I mean. Now here it is AB and PQ, they are in the same. AB and PQ equal to BC by QR equal to AC by PR we have. Now AB, here you see we have AB. Okay, let me mark here AB. Another by PQ, let me mark here PQ, this is PQ. Okay, now these two sides are called corresponding sides, and the angle you have opposite to this is angle C, opposite to this is angle R. Those angles C and R are called corresponding angle. Okay, so if angle C and R is corresponding angle, then the opposite side is called corresponding side. So if the side AB and PQ is corresponding side, then the opposite angle is called corresponding angle. That is all about corresponding side and corresponding angle. Now here we will learn, in the two triangle we find three angles are equal. So if three angles are equal, then the two triangles are similar. They will be exactly similar. Okay, they will be similar. Then other is, if the corresponding sides are proportion like this, ratios of the sides are equal, then the triangle is, again we can call it similar. So these are the two conditions under which we can say the two triangles are similar. We may not look at the triangle, but directly also we can say that if two triangles are similar, if the corresponding angles of two triangles are equal. If the corresponding angle of two triangles are equal, then we can say the two triangles are similar. Also we can say the two triangles are similar if the corresponding sides of two triangles are proportional. That means the corresponding sides are in the same ratio like this, AB by PQ equal to BC by QR equal to AC by PR. That is called proportional. Okay, so that's very important point. Two triangles are similar if the corresponding sides of two, or the corresponding angle of two triangles are equal, like here. All the three angles are equal, then we can say the two triangles are similar. Also we can say the two triangles are similar if the corresponding sides of the two triangles are proportional. That means when you divide the two sides of the triangle, these two sides, and this side, when you divide it and you get the same ratio, then we can call it proportional. So if the corresponding sides are proportional, then also we can say the two triangles are similar. So those are the two conditions under which we can say the two triangles are similar. That means here we find, what do we find in this two triangle is their three angles are equal. So if the three angles are equal, then we can say the triangle ABC is similar to triangle PQR. PQR. And this symbol, a symbol of wave, is the symbol of similarity. Similarity, you can say. I'll write it down here. This is symbol of similarity. Okay. Theorem 6.1 of page number 129, and the question is like this. This is very important theorem. It comes in examination. Okay, this is very important. It comes in examination for 5 marks. Theorem 6.1, page number 129. You can take out the theorem there in the page in your textbook, and the statement is given here like this. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, the other two sides are divided in the same ratio. Only this much will come in examination. The rest, all the things you need to do by yourself. Only this much will come. Okay. Now you have to draw the figure. You have to prove all the things you have to do by yourself. Let us see the question once again. If a line is drawn parallel to one side of a triangle, so what you do? We will draw one line. We will draw a line parallel to one side of a triangle. So let's draw one triangle. I already have drawn the triangle, and it is triangle ABC. There a line is drawn parallel to one side. We will draw one line parallel to one side of the triangle. There are 3 sides here, AB, BC and AC. 3 sides are there. Parallel to any one side, we will draw one line. So let me draw one line here, parallel. This line I have drawn. Let me give a name here, DE. Okay, so this line DE I have drawn parallel to BC. DE parallel to BC. Given triangle, given is triangle ABC, there DE parallel to BC. Line DE is parallel to BC. And then after that, to intersect the other two sides in the distinct point. See, this line DE is parallel to BC, and this DE is intersecting the line AB at one point and intersecting the line AC at one point. That is a distinct point, means that you can see it visibly. That is separate points. The other two sides are divided in the same ratio. That's what you have to prove. The other two sides are divided in the same ratio. This you have to prove. The other two sides, that means DE is parallel to BC. So the other two sides are what? AB and AC. Now we have to prove here that AB and AC is divided in the same ratio. To prove, we have to prove here same ratio. That means AD by DB equal to AE by EC. That is called divided in the same ratio. That means the value of AD by DB will be how much? Maybe 1 by 3. Like that, AE by EC will also be 1 by 3. Just for example, 1 by 3. It could be say any other value. Okay, so the ratio must be same. Now for that we have to do certain construction here. Construction that is by our own. That is not given anywhere there in the question. We have to do our own construction, and that is a very important part of the solution. In construction, what you do is we will draw one perpendicular from point D to the line AC. We will draw a perpendicular. You can check it out here. I am going to draw a perpendicular. See, this is a perpendicular. Perpendicular here, that means it is 90 degree. And then another perpendicular will draw from the point E. Let me draw another perpendicular from the point E. Here it is. This is perpendicular. So let's give one name there. We can give the name here P and here Q. All right. So DQ is perpendicular to the whole line AC. Like that, EP is perpendicular, or you can say PE also you can say. EP is perpendicular to the whole line AB. Construction, we have drawn DQ perpendicular. This is a symbol of perpendicular to AC. Likewise, EP is perpendicular to the whole line AB. That's what we have to draw. After that, what you have to do is we have to join DC. These 2 points we will join. And join EB. See, both the lines are both the points are joined here. That means joint DC and BE. Okay. After that, we will have to start solution. That means proof will start now. Now, first of all, what you'll do is we will find the ratio of the triangle ADE and the triangle BDE. We have to find out the area of triangle ADE. You can see the triangle ADE, area of triangle ADE. All right, and that area of triangle ADE we will divide by the another triangle. So you can see here triangle ADE, and another triangle will take. One thing more to note here, I am considering the side AD as the base. Now, we will take the triangle ADE as I have taken here. Then the next triangle we will take is a triangle which is attached with the triangle ADE and also have the base on the left side BD. I am taking the side AD as base. Here I will take the base as BD. So when you take the base as BD, then we get the two triangle here, DBC, another is DBE. So I will not take DBC. Why I will not take DBC? Because the triangle DBC is not joined. See here, is not joined. See, this DBC is not joined with ADE, is not joined. Now if I take the another triangle here, if I take the triangle DBE, it is joined with the triangle ADB, ADE, and BDE is joined. So because of that, we will take those two triangles which are joined, attached. Okay, it is having one side common. So that will be divided by the another triangle. What did I say? BDE. Area of triangle BDE is equal to area of triangle. The formula is half into base into height. Area of triangle, the formula is what? Half into base into height. Half into base into height. Okay. If it is half into base into height, something like this, then for the triangle ADE, for that base is AD. If base is AD, then the height will be the line which is making 90 degree with it, that is EP. Half into base AD into the height is PE, or you can say EP, by half into, for the triangle BDE, for the triangle BDE, again formula we use half into base into height. Half into base is DB into height. Now for the triangle BDE, I am going to shade it lightly for this triangle. Okay, can you see this shading bit of it? I hope you can see that. Okay, now this triangle has the base BD, but it does not have any line which is making 90 degree. See, this ED is not making 90 degree. This is not 90 degree. Then where is 90 degree? This is not 90 degree. Then where is 90? 90 is here. 90 angle is here. So this will be the 90-degree angle, I mean the perpendicular for the triangle BDE as well. For both the triangle it will be. So the triangle BDE has the height, that is EP. So this is a triangle. BDE is a triangle where there is no 90-degree, and here the angle is more than 90. That means the triangle is an obtuse triangle. So if it is an obtuse triangle, then obviously it will not have 90-degree. 90-degree will be outside the triangle. So that also can be taken as a perpendicular. So area of triangle ADBE by BDE equal to half into base into height. Here also half into base into height. So this we have taken, since area of triangle equal to half into base into height. This formula we have used. The next what you do is, we will cancel this half and half, EP will cancel, and then what do we get is AD by DB. AD by DB. Then in step number 2, again we will divide the two triangles, and the triangles are something like before. One triangle is ADE, this triangle you can see here, ADE, this triangle, area of triangle ADE. So I am going to write here area of triangle ADE, divide by the another triangle. This time, earlier I have taken the side AD as the base, so I concentrate and I took the other triangle DBE. Now I will concentrate on the right side as the base. I will try to take AE as the base. This one is the base. So the other triangle that I am going to take, one triangle I already have taken ADE. Okay. The other triangle that I am going to take is a join with this, and the base is EC. That means the triangle I am getting here is CED. That is a triangle which is joined with ADE as well as having the side base on the right side. So divide by the triangle, area of triangle CED equals to, again the formula will use half into base into height. Half into base into height for the triangle ADE, same like before, but the base and height will change this time. Area of triangle same like before, but the area of the formula will change, and base and the base and height will change. The formula will not change. Formula will be half into base into height. So let's take the base. Base is AE, and the height. On this base AE, you have perpendicular DQ. So DQ will be the height. DQ will be the height. So half into base into height. Likewise again half into base EC into height. Again here in this triangle CED, okay, in triangle CED, in this triangle CED, you can check out here. In this triangle CED, there is no 90 degree. 90 degree is outside here, so that will be the perpendicular. So the perpendicular will be the line DQ. Perpendicular will be the line DQ. Then we will cancel. This is because of area of triangle equal to half into base into height. Now we will cancel this half and half, DQ and DQ. One thing very easy to remember is, both the height will be same, like EP will be same, DQ will be same. That's easy to remember. Then we get here AE by EC. Okay. So here what do you find is area of triangle ADE by BDE, area of triangle ADE by CED. The difference between the two ratio here, see, these two triangles are same, but these triangles are different. Then what you have to prove? Let us check. We have to prove here AD by DB equal to AE by EC, and we are having here AD by DB equal to AE by EC. These two things you have to prove equal. Now in order to prove these two things are equal, we have to prove left side triangle at the bottom and triangle at the bottom, that is if we can prove the triangle BDE and CED are equal, then we can say left side is equal. Then if left side is equal, then the right side will also be equal to one another. So the problem is here with these two triangles BDE and CED. Now we have to solve that. Before we solve, we have to look at the figure. If you look at this figure, what do you find is triangle BDE. BDE. Another triangle is CED. CED. Both the triangles, if I close this side, then you can see it easily. Both the triangles are on the same base. They are standing on the same base. One triangle is this one triangle is this one. Both the triangles are standing on the same base. And another thing, what do you find is both the triangles are between the same parallel line, because DE and BC are parallel line. So the two triangles are on the same base as well as between the same parallel line. So if the two triangles happen to be so, means on the same base and between the same parallel line, then their area will be equal. That means we can write here step number 3, this area of triangle BDE is equal to area of triangle CED, because both these triangles are on the same base and between the same parallel. Since triangles are on same base and between same parallels. Okay. So what do we learn here? Two triangles are equal in area because the two triangles are on the same base and between the same parallels. So that means we get here these two triangles are equal, BDE and CED. They are equal to one another. And we already know that ADE and ADE are equal. So what do we conclude from here? Left side is equal. So if the left hand side is equal, then we can say the right hand sides are also equal. Number 4, we can write the right hand side equal. What is the right hand side? AD by DB is equal to AE by EC. So that's what we had to prove. You can check it out. It is here to prove AD by DB equal to AE by EC. And we get just now in step number 4, AD by DB equal to AE by EC. So it is proved. And this we come to know from step number 1, 2 and 3. From step number 1, 2 and 3. That's what we had to prove. Done. Now I am going to write down the conclusion that we draw from theorem 6.1, and it is like this. Conclusion: if in a triangle ABC, we take the triangle ABC, there in the triangle ABC, if DE is parallel to BC, if the line DE is parallel to the line BC, then what are the things we can write? We can write AD by DB equal to AE by EC. That's what we proved just now. Okay. Likewise, also we can write the another ratio. We are not going to prove, just I'll write down the ratios only. What are the things we can write if the triangle having one side parallel to the, if we draw one line parallel to the one of the side of the triangle. The other ratio we can write is AD by AB equal to AE by AC. Something like this, AD by AB equal to AE by AC. This AE by AC, like this we can write. Then third, what we can write is DB by AB is equal to EC by AC. That also we can write. So this is the conclusion from the theorem 6.1, that in a triangle, if a line is drawn parallel to one side, then we can say AD by DB equal to AE by AC, another AD by AB equal to AE by AC, DB by AB equal to EC by AC. Okay, these are the things which will be helpful in solving the next exercise. So keep the things ready, written in your copy. So we do this much in this video. Thank you.